Assalamualaikum, my name is Muhammad Nazmi bin Sulaiman, number matrix CD210292. Firstly, I would like to explain about our introduction. For the introduction of our topic, which is buckling column, firstly, what is buckling? Buckling is a deformation in column when axial load is applied, which is a compressive load. In other words, we can say that structural member or building elements which don't support a provide load and changes in its shape is called buckling. Next, we have objectives of our project. Firstly, for our objective of this project is to understand the column buckling concept, which, as I explained before, where the buckling is the deformation in column when axial load is applied. For our second objective is to be able to conduct an experiment involving the concept of buckling column with various different type of column and different length of column. Then lastly, we have to analyze the performance of column under compressive load, evaluating how the length of the column and type of column affect the column behavior.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Lukman bin Muhammad Syuib. So today, as you can see, I will tell you about how to make the experiment and also what the apparatus that we need for the experiment. Let's go to the apparatus first. So the apparatus that you might be need for this experiment is first, the most important is the machine, which is the buckling column machine. The machine, as you can see, you can make it by yourself. It's just a simple way and a very affordable for you. And the second apparatus that you will need is the scale. The scale will be used to measure the load that had been put in the machine. And the next and the most important substance or apparatus that you need is this beam. This beam you can make with any type of material, but today we will choose polypropylene substance or material that will present that will be our beam to test the column of buckling, the buckling of the column in our experiment. So it should be two of this beam, which is 130 centimeters and the other is 35 centimeters. And all of this apparatus will be used in the tutorial of the experiment that I will also explain in the next slide or in the next video. So stay tuned, I will come up next. So we meet again for the tutorial of our experiment. So after knowing all the apparatus and getting all the apparatus, this is the setup of our experiment procedure. So this is the beam that we will use, 35 centimeters, and we will also use the condition of fixed here, fit at the platform and also at the bottom of this apparatus, this machine already fixed and fixed. So what we need to do is we will put some rice as a load here at the upper part of the machine. So let's begin for putting some, and we will see at what weight that this column will buckle, and after that we can calculate for the critical load. It start to buckle also. That's all for the experiment. You can see it's already buckled. See here, the beam already buckled, and so we will calculate for the weight of the load that we already applied. You can see this is the scale. I will put it in my side so that we can know what is the weight of the load. Okay, this is the result of our experiment, which is the load. Wait for this pin to be buckled is around 650 gram. So all we have to do now is just put the measurement in our data sheet, and we can calculate for the PCR the critical load of our beam, respective beam for the fixed feet. And we also need to do 3 more tests so that we can get the result for the fixed pins for the 35 centimeters and fixed feet for 30 centimeters and fixed pin for 30 centimeter beam also. So that's all from me. Thank you. See you again.
Good day everyone, my name is Yogendran Sano Subramani, metric number CD210005. Today I would like to explain about the calculation of our report, which is have two type of column, which is the fixed and fixed to pin. We calculate the fixed to fixed column, which is 30 cm is 7.86 kilonewton, and for the 35 cm is 5.5 kilonewton. For the fixed and pin, we get 3.82 kilonewton and 28.1 kilonewton for the fixed pin column.
Assalamualaikum. Now I want to discuss about discussion. After our group collect the data and make a calculation, first thing that we prove is the theoretical value are compared with experimental value and the result are tabulated in data. Percentage error for fits between 50.19% and 90.83%, while for fixed pin is between 51.28% and 68.24%. There are several factors that contributed to the difference in theoretical and experimental results. The percentage error calculated range of two situations between 15.90% to 19.83% and 51.28% to 68.24%, which is quite large as the experiment was carried out using simple equipment. The result for fits smaller percentage than result percentage for fixed pin. In a nutshell, the longer the length of the steel, the higher the critical load. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Salman bin Ahmadi, Nometric CD 210258, and today I'm going to talk about conclusion. As a conclusion, out of two types of column, which is fixed to fixed column, fixed to pin column, we know that fixed to fixed column has the highest or largest critical load value. By comparing the critical load value, we know that fixed to fixed column can sustain more heavier load than fixed to pin column. Another factor that affect the critical load value is the length of the column. In our experiment, we calculate the PCR or critical load value, and we found that when the column has the shorter in length, it will have the higher critical load value. In short, the column with shorter in length and fixed to fixed configuration are the best column design to support a greater load while not easily experience buckling. Thank you.
Assalamualaikum. My name is Muhammad Hazmi Muhammad Zamri. My matrix number is CD210070. Okay, now I want to discuss about recommendation. In this experiment, the principal sources of error are: first is poor enforcement of boundary condition with the support blocks, and the second is failure in the maintaining the structure level load while loading the column, causing and non-uniform loads. And lastly is imperfection with the specimens, including pre-buckling. The first reason, which has to do with boundary condition, is the most important of the one mentioned above. A non-zero slope at the end of the specimen during the compression may have been caused by the weak clamping system in the support blocks. Changing the boundary value, a better clamping system need to be used in the future test. And second one is new specimen should also be employed, and the end electrical device that automatically levels the column without requiring human input should be implemented. Okay.